Today's notes are brought to you by Silly Cat Photos, and our title is 8-5 Law of Sines. Since you're seeing sines here, that means we're going to be looking at our trig functions again, and this is a relationship between in a triangle that's related to the sine function. In your notes today, I'm going to show you why the law of sines works, and we're going to actually write it, and then we're going to go over 3 examples. So why does the law of sines work? What is the law of sines? Well, we'll start with this. Start off by drawing this right triangle with the altitude h, and I'm going to move this over. What I'd like you to think about is this triangle and this green triangle that are within that larger triangle in there, that larger right triangle. So the first thing I wanted you to think about is this red triangle right here. If I was going to find the sine of angle A, it would be the sine of angle A is equal to the opposite length over the hypotenuse. So it would be h over b. And the sine of angle B would be the opposite over the hypotenuse. Now we're looking at the green triangle. So that would be h over b. Now, over A. Let me erase that guy. Over A. So now, if we do a little bit of math here, if I multiply by b on both sides, and I multiply by a on both sides, I end up with this equation. B times the sine of a is equal to h, and here I get a times the sine of angle B is h. Now, what I hope you're noticing is that both of these equations equal h. That means I can set them equal to each other. I can take this value and set it equal to this one. When I do that, I get b times the sine of a is equal to a times the sine of angle B. Now I'm going to do a little bit of math here. I'm going to divide by b on this side and over here too. And I'm also going to divide by a. So I'm going to divide by a and b. Now what happens when I do that? Well, my b's become 1, my a's become 1, and here's where the law of sine is born. I get the sine of a over its opposite side is equal to the ratio of the sine of b to its opposite side. And that's actually where the law of sines comes from. So to be more specific, here's what the actual law of sines says. For any triangle ABC, let the lengths of the sides opposite the angles A, B, and C be A, B, and C respectively. Then the law of sines relates the sine of each angle to the opposite side as follows. Now that doesn't make a ton of sense. Let me show you what they're saying. You have angles A, B, and C, and have their opposite sides be A, B, and C. Then the sine of each angle relates to its opposite side. And it just so happens that all of those relationships are the same. So the ratio of the sine of A, B, and C over their opposite sides are all equal. And this right here is the law of sines. So let's try using the law of sines, starting with example 1. It says, use the law of sines to find the missing value, round to the nearest tenth. The first thing I want to do is look at the different angles I have. So I have angle 63, and I'm given its opposite side, and I have angle 71 and its opposite side. That means I can use the law of sines. That means the sine of 63 degrees divided by its opposite side, it should be equal to the sine of another angle, 71 degrees, and its opposite side. This is a proportion. Now, all I'm going to do right now is cross multiply and divide. So I'm going to cross multiply, and I get the sine of 63 degrees times x equals 18 times the sine of 71 degrees. Now, I'm going to divide by the sine of 63 degrees to get x by itself. And here's where we're going to start doing some substitution. Now, x is equal to 18 times the sine of 71 degrees divided by the sine of 63. So we need to find these values. The sine of 71 is right here. It's 0.9455. And the sine of 63 degrees is 0.891. Now you're going to be really happy to hear that you do not need to take this any further. So I'm not going to make you round to the nearest tenth. So for you, like on a test, you could leave your answer like this. Now because I happen to have a calculator with me, I'm going to go ahead and tell you what would have happened if you had divided everything out, multiplied and divide. You would get x equals 8.489. And if I round to the nearest tenth, you would get x equals 8.5. But because it's a little bit too much of calculations for me to ask of you, I'm going to ask that you just leave your homework and your tests and quiz like this when you use the law of sines. Now let's look at example 2. Here they say, use the law of sines to find the missing value, round to the nearest tenth. So again, I'm going to look at the angle I've been given. I have 63 degrees, and I was given the opposite side. And here's my problem. I was given 71 degrees, but not the opposite side here. I was given this side, but not its angle. So what do you guys think I should do? Well, here's the cool thing. This is a triangle whose angles add up to 180 degrees. That means that this angle plus this angle plus this angle equal 180. So what is this angle? Let's do a quick little bit of math. So take 180 minus 63 and 71, and we end up getting 46. That means that this angle in here is 46 degrees. So now I can use the law of sines. I can say that the sine of 63 degrees divided by its opposite side, that's equal to, now I have another combination, those are my green angle, the sine of 46 degrees is divisible by y. Now I'm just going to work with that proportion. Remember, I'm going to cross multiply and divide. I get the sine of 63 degrees times y equals 18 times the sine of 46 degrees. I'm going to divide by the sine of 63 degrees on both sides. And when I do that, I get y equals 18 times the sine of 46 divided by the sine of 63 degrees. Now, this is where you should feel very happy because you're almost done. I still have to do a little bit of math. First, we have to find the sine of 46. It's right up here. So that's 0.7193. And the sine of 63, we use that one. Maybe you've memorized it by now. It's 0.891. Now, for you, on a homework assignment or on a test or a quiz, this would be where you would stop. Since I did the calculations, I can go a little bit further, and I do want you to write this down. If you multiplied and divided, you would get y equals 14.531 repeating, which means if we round to the nearest tenth, since that 3 does not affect the 5, I get y is approximately 14.5. That's the distance of that one side. For our last problem, I'm going to ask that you finish it, but I'm going to help you start. For example 3, it says use the law of sines to find the missing value, round to the nearest tenth. I have my triangle right here, and I'm going to start by identifying some angles. I have 41 degrees with its opposite side y. Okay, I have the 14 side, but I don't have an angle. And last but not least, I have 62 degrees and its opposite side. So I do have some parts here, but I'm missing this angle. So we're going to go ahead and do our calculations. I have 180, and I'm going to subtract 41 and 62. And when I do that, I'm going to get, do you know what I'm going to get? It's 77. 77 degrees. Now, in order to find an x value and a y value, that means I'm going to have two different proportions. I'm going to write one of them for you. So I'm going to start off with, I'm going to choose the red, the sine of 41 degrees divided by y. I'm going to set that equal to the only sine function relationship that has two values in it. So that's the green one. So the sine of 77 degrees divided by 14. Now I'm going to leave this like this, and you're going to have to cross multiply and divide and do your math here. I'm going to go ahead and tell you that when you finish, y is approximately 9.4, just so you have that on your paper. Remember, your answer will come before this, though. Now you have one other ratio or you have one other proportion to set up, and I'll only tell you this. The sine of 77 degrees divided by 14 will be a part of that. So I'm going to leave this open for you. What I'd like you to do right now, let me go ahead and set this up so you can clearly see it. There are two parts to this. You're going to need to finish this proportion and plug in your sine values. And for your second part, to find x, you're going to need to find out what that sine ratio is right here. Cross multiply and divide. And let me give you your answer for your second one. X is going to be approximately 12.7. But again, remember your answer is going to be one step before that. Go ahead and put in the math, and when you're finished substituting in your sine values, you can move on to your next station.